Good afternoon. My name is Dwayne Davis. I'd like to welcome everyone today to our webinar entitled Hipot Testing Basics. This is part one. We've split this webinar into two different sections, mainly because of the length of it and the questions. It ended up being roughly about 90 minutes in length, so we're going to do this into two different sessions and stuff. So we've redone this webinar. Again, I'd like to welcome everybody today. I'm Tech Support Manager for Associated Research. I've been here 44 years. Assisting me today is Rebecca, and she will be hosting the webinar. If you have any problems with the audio or visual presentation, please address those questions to Rebecca through our chat line. And both Pete Stevens and Syed are also assisting in trying to answer any questions that you may have regarding the material being presented. So if you can use our Q&A facility and address those to either Syed or Peter Stevens, that would be very helpful, and then they will either answer your questions or redirect those to me during the presentation to try to answer your questions as we go through the material. Okay, with that being said, let's run through the outline real quick. We're going to talk about the different types of Hipot test and essentially what they're accomplishing or what they're trying to do. What is the purpose of their different types of these tests, and just how are some of these conducted. We're mainly going to be talking about the routine production line test. Basically, how do we make pass-fail judgments? How is that determined? What we need to do as part of our daily routine to verify, the equipment briefly. Talk about the differences between leakage, breakdown, and arc failures. What we don't, all this material will be covered today. Next week on Wednesday morning, we're going to be doing part two, which is going to be going more in depth into a little bit on some of the Hipot testing applications and problems and stuff you may run into. Okay, let's talk a little bit about the different types of Hipot test. First off, a breakdown test. A breakdown test is essentially a design test. This test, by its nature, is in fact a destructive test. It's done on a sample basis to actually determine what the breakdown voltage of the insulating material is. Now, that insulating material might be a solid material, it might be a liquid, it might be a gas. Depending upon the type of material, the application may vary a little bit, and the specifications that you're actually testing to. If you're doing dielectric oil withstand testing, that might be done to like ASTM D877 as an example. If you're doing solid dielectric material testing, that might be done in accordance to ASTM D149. But in any case, how this is typically done, you may have different styles of electrodes. Your rate of rise may vary a little bit, but you gradually increase the potential until the insulation between the two conductors actually breaks down, where it fails. An arc normally will occur, jumping the gap or puncturing the insulating material or flashing through the dielectric material if it happens to be a liquid. Okay. Typically, the Hipot tester has to have a high enough output current capacity so the voltage does not sag once that arc is initiated, and you normally have a tester that has some type of a meter memory that retains the actual breakdown reading of the potential that was applied when the sample failed. Again, this is a sample test. In order, you normally run a number of samples or a number of tests on this sample just to try to get an average breakdown voltage, because if you're doing a solid dielectric material test, the size of the electrodes, you may use different, maybe a 1/4 inch or 1 inch or a 2 inch diameter electrode, depending upon the size of the insulating material. The number of tests, normally you might run 5 samples on it to come up with an average of what the actual breakdown voltage is of that material. But anyway, a breakdown test is in fact a destructive test. This test is not something that you want to do at the end of your production line. I don't want to buy a product that you've ran a breakdown test on. It's not going to work very long. Besides that, it could create some kind of a shock hazard to the individual trying to go through and use it. So if somebody asks you what type of Hipot test that you're doing, I hope your answer is that you're not doing a breakdown test, that you're doing a dielectric withstand test if it's on a product that you're selling to other individuals and stuff. But anyway, okay. What is a type test? A type test is also a design test that is done, on an engineering level. It might be done by either a technician or an engineer. It may be done by a safety agency, and typically this test is done on a representative sample of the equipment. The objective of the test is to determine if the equipment, as designed and as it is manufactured, can meet the requirements of the product safety standard. These tests are normally conducted, again, like I said, by engineers and technicians. They go through and they evaluate, the design of the product. They're checking for various problems or design issues that may occur with the product itself. When you're talking about a Hipot test, you're talking about creepage and clearance distances. Within the design of the product itself. And again, this is going to be based upon the application of the product. Is this product, what is the category of the insulation? Is it a product that is meant for outdoor use? What kind of pollution degree could be expected with the product itself? And what I mean by that, is it a dirty atmosphere that your product could be used in? Dirt is a conductive material. So again, your design criteria may be a little different for that type of product than what it would be for a product that is essentially sealed, where no foreign material and stuff could come within the product itself. So, these are some things that have to be evaluated from a design standpoint and from the standard that you're testing to. Again, make sure that you're testing your product to the appropriate standard, based upon the application. If it's a small appliance, is it a medical product, information technology equipment. All of these different types of product have different specifications to go through and evaluate the design of the product under. The duration of the test may vary. The applied voltage may vary. If you're testing either the basic insulation or reinforced insulation, your test voltage is going to vary. The basic insulation might be anywhere from an 875 volt test up to potentially a 1500 volt test. Double insulated might be a 3000 volt. If you're talking a medical product, this could be a 4000 volt, potential that is being applied to the product itself. So you will see some variations depending upon, the type of product that you're manufacturing and stuff also. Okay. The routine test. Okay. This is exactly, what it is meant to do. This test is not intended to be a destructive test. It is intended to reveal variations that could occur in the manufacturing process that could impair the safety of the product itself. Again, these tests are normally performed on the completed product after everything is fully assembled, essentially before the product is packed up and ready to go, at the end of your production line process. A routine test is more of a go, no-go test. It's done at the end of your production process. It's normally done at a shorter time duration, where a type test might be done for a 60-second period of time, where your routine production line tests are normally done anywhere from maybe 1 to 5 seconds. They could be done at a 60-second interval or time period, but normally they're done at a reduced time just to try to increase your throughput. So you're not spending a lot of time at the end of your production line going through and testing these products. The test may be done at a higher potential. It is very common to see an increase of maybe up to 20% over what the potential is during a design test. You might see a production or a increase in the test potential 20% higher for a routine production line test. That's very common. Okay. But, these tests are normally done at the end of the production line, and again, their intent is to reveal any potential safety problems that could have happened, such as cut insulation or component spacing that might be too close. It's not necessarily going to detect an improper component if you install a wrong part in it. It could, depending upon where that part is at, but it doesn't test the the routine Hipot test. Would not detect a line to neutral short, because when you perform this test, you're tying those two parts together and you're applying high voltage to both the line and neutral conductor simultaneously, and you're testing the insulation between what is normally your current carrying conductors to the exposed dead metal of the product itself. Okay, a maintenance test, or this is another type of Hipot test. There's a lot of controversy that goes on about retesting a product. Should I go through and perform a Hipot test on the product after the thing is initially shipped? Should a maintenance test be done on it? Am I overstressing the insulation in going through and doing this test? One of the big things I think people fail to realize is many of the maintenance tests are done at a reduced voltage. A common test might be done at 60% of what the factory test voltage is. part of the reason for this is if the product has been working, you just want to verify that the insulation is good. You don't want to overstress it to the point where you could possibly, cause damage to the insulation. But you do want to weed out anything that might cause a potential shock hazard to the individual that may be using the product. Face it, that's the whole purpose of the Hipot test, is to find these types of problems. So, do you perform a maintenance test? It might be a good practice if done on certain types of products. I've heard that, over in Europe and stuff also, that like tool rental companies have to go through and retest a product before they can rent it out to another individual, just to make sure that it wasn't damaged by the previous user, this type of thing. So that's probably a pretty good practice. I would feel much safer using a tool that I know that was tested recently than one that wasn't tested. Okay. Let's talk about the routine Hipot test. What is done at the end of your production line? What is it designed to do? Again, this test is a deliberate application of a high voltage potential that is designed to stress the insulation far beyond what it will normally encounter during its normal life cycle. And it's assumed that if the insulation, in fact, can withstand this much higher potential for this given time period, it will be able to function adequately at its normal level throughout the life cycle of the product itself. And this is where the term voltage withstand test essentially comes from. But it's not meant to be a destructive test. It is done as a routine test to try to find problems that may have occurred during the manufacturing process, this kind of stuff. Who needs to actually perform a test, a Hipot test? Well, if you're manufacturing an electrical product and it's operating from line power, you really should be performing this Hipot test, or routine production line Hipot test, on each and every product that you produce. This test is really done to protect the user of the equipment from any potential electrical shock hazards that might occur, due to faulty insulation within the product itself. Let's face it, you cannot totally prevent somebody from misusing a product and potentially getting shocked as a result of that misuse. But you can make sure that the product as designed, and if it's used as it's intended for its intended use, that it should not perform or create a potential shock hazard to the individual. The Hipot test is incorporated at the end of the production line. Each and every instrument that is produced or product that is produced should be tested to make sure that that insulation does not fail whenever this high voltage potential is actually being applied to it. So the Hipot test is a very important test just to make sure that you are not creating a potential shock hazard, for the user. What types of problems are actually detected by a Hipot test? One of the major things, you could have excessive leakage current in the product itself. What kind of problem would that create? Depending upon the type of product, if it's a product, let's say it's a Class 1 product, and that Class 1 is designed to have any exposed dead metal connected to earth ground. Okay, so it's operating from essentially a three-prong plug, and that it's grounded. If there's excessive leakage current, that leakage current should be safely routed to earth and not through the operator. But what happens if that ground circuit is faulty? Then that leakage current could end up flowing through the individual. If you're not running from any type of a GFI type outlet or protected outlet, that leakage current could create a significant shock hazard to the user. That shock hazard could, at a minimum, create a startle reaction. Under certain conditions, it could be lethal. Depending upon the path of current, what if that person that happens to come in contact with that product is, maybe they're wet. Maybe they just came in from a rainstorm and, came in contact with a product, or they're using that product outdoors. There have been, articles and stuff that I've read where, kids were electrocuted getting out of a swimming pool and coming in contact with a lamp, just trying to move it, because the product was not effectively grounded. The product was not necessarily faulted, but because it wasn't grounded, the leakage current ended up going through the girl, and she died as a result of coming in contact with that light, trying to move it after just getting out of a pool and stuff. This happened a few years ago down in southern Illinois. But anyway, weaker damage insulation resulting from an electrical breakdown. This is a type of defect that we try to find by doing a Hipot test. Foreign material that might be, or voids within the insulation itself, these type of defects can be found during a Hipot test. Some types of manufacturing defects, some types of wiring errors. If you reverse a hot and a ground wire, or a neutral and a ground wire, and you go through and you do a Hipot test, it's going to fail because you are testing either one of those two circuits, to ground. Improper spacing with respect to ground. This type of defect can also be located. By applying, the high voltage potential, it could jump that gap and, create a shock hazard, to the individual and stuff. If there may be some type of a voltage surge or something that would go through that product while the product is actually being used. What causes insulation failure? Heat, can actually melt or damage the insulation. It could be damage from handling, scrapes rubbed across a rough surface. Sometimes the insulation can be damaged just due to shipping, the vibration that occurs. If a wire happens to be, contacting a metal surface. I've seen this in some motor applications and stuff where you might have a magnet wire, in the motor itself, where it may be contacting, part of the motor, and in shipping the thing across country, the vibration damaged that varnish insulation, where when it got to the customer's location and they went through and Hipotted the end product, found that the product was actually failing, and it was due to this wire actually being too close, where it was actually coming in contact with the metal frame of the motor itself, and you know, in shipping, the just the vibration and shipping damaged the insulation where it failed. Okay. Pinholes in the insulation. Wires can be pinched. You can have crimps that damage the insulation. Again, improper spacing with respect to ground. These are all types of failures that could occur. When you're performing a routine Hipot test, what are you actually doing? This is a very simplified circuit here. Our Hipot tester is basically just showing a high voltage transformer, and the secondary of this high voltage transformer is, you know, the high voltage comes out and it is connected. We supply an adapter box that goes with many of our products and stuff, where you can, if you're testing a product that has a 2-prong or a 3-prong plug, it makes it much easier to go through and be able to perform the test. And inside the box, we essentially short the hot connector to the neutral connector, and both of those are tied to the high voltage. Okay. What we're doing there is we're making sure that we're applying a high voltage potential to both sides of the line, and we are connecting the return from the Hipot tester, you know, essentially to any exposed dead metal on the enclosure of the product itself. So the high voltage potential is applied to whatever components and stuff may be within the product. You know, if there's a capacitor, volt, you know, windings, you know, an indicator light, you know, whatever is within the product itself, the same potential is being applied to both sides of these components, and we're essentially then testing the insulation between these components and the enclosure, both on the hot side and the neutral side of the line. It's important to make sure that if we have a power switch in our device, that power switch is on. So we're testing the entire circuitry of that product. Whenever we're going through and we're doing this test, we're applying this high voltage potential to all of these circuits simultaneously, and you know, we're testing the insulation between what are normally current carrying conductors and what is not meant to be a current carrying conductor, which is essentially the enclosure of the product itself. We have a voltmeter that is connected directly across the output, so it's right between high voltage and the return to make sure that the potential that we're applying is correct. We have a current meter in series with the return, along with some type of a failure detection circuit that monitors how much current that is actually flowing through the return. With that, you know, you can adjust and set trip points, so if you exceed a certain current flowing through the product, it will generate a failure. The design on most of our products also have not only a high limit, but also a low limit that you can set. Why is that important? Well, the low limit setting makes sure that at least a minimum amount of current is flowing through this circuit during the test. And it's just a way of guaranteeing that you are performing a test on your product. If you have one of our Hipot testers and it's got the capability of setting a low limit, I suggest that you use it. Why? Test leads open up, okay, just due to handling. If either the high voltage or the return circuit is open, current will no longer flow through this you know, item being tested. And if that happens, you haven't done a good test on your product. So, you know, How do you check for that? Well, you should be doing some type of a daily fail verification test on your product. At a minimum, I would suggest short high voltage to the return. The best thing to do is if you have a known bad product that you can put in and test every day, at least once a shift, then plug it in and run a test on it. Make sure it does fail. This is accepted by most of your safety agencies and stuff. They typically do not like you just shorting high voltage to the return. They don't consider that to be an effective, good test. They want you to either have some type of a known bad product that you're testing, or something where you're actually monitoring the current flowing through this circuit to make sure that it will pass or fail whenever you're going through and doing this test. Okay. This is showing a photograph of one of our Hipot 3 category of instruments, and it actually shows the connection using one of our adapter boxes here. We've got the high voltage that comes out and goes into the adapter box where the line and neutral circuits are tied together internally in this box. So we are applying the high voltage potential to both the neutral circuit and the hot circuit simultaneously. And we're testing, again, the insulation of our device under test to ground. This is showing the ground connection coming back, into the ground pin here, and that's connected to the continuity terminal. Okay. The return terminal is connected to the chassis. What is this extra connection here that I didn't show in the other photo, okay, or the other diagram? Part of the test, if you're testing a product that has a 3-prong plug on it, one of the tests you are required to do is verify continuity between the ground blade of the attachment plug, okay, which is, I'm going to get rid of these other circuits here and talk about that briefly, okay. So between the ground blade of the attachment plug and the return of the Hipot, okay, or to the to the chassis. So I'm making sure that this item is in fact grounded through its line cord or through the IEC connector or whatever. But I have to check that circuit for continuity, and we normally will go through and do that test. Some standards will specify a maximum resistance of that ground circuit, some will not. Many of our Hipots have a 1 ohm maximum continuity. Some of them have an adjustable continuity circuit. Some standards may specify a maximum resistance of 0.1 or 0.2 ohms on the ground circuit. Others do not. Again, some of them may say you can use any indicating device, a battery buzzer combination or the like, to test for ground continuity. The problem with that is if your resistance of your ground circuit is actually too high, then in some cases you could never pump enough current through that ground circuit to generate a fuse or circuit breaker failure should the insulation within the product fail itself. The whole purpose of that ground within your product is to provide a low resistance path for any fault current to flow that will cause the circuit breaker or fuse to trip to protect you against an electrical shock hazard. it is there also to make sure that the resistance is low enough that no voltage will elevate high enough that would cause a high enough potential on the enclosure that would create a shock hazard also. So, you know, that ground circuit is very important within the product itself. So it is very important that this circuit be tested, you know, for continuity at a minimum. Either that or you should be doing a ground bond test on that circuit to, you know, to verify that the resistance is low enough and that that ground circuit has the capability of tripping off, so it does not act like a fuse should a fault occur within the product itself. Okay. Okay, a little bit more of a schematic diagram showing some the internal workings of the product itself. This is a very simple circuit. We're talking about a lamp here. You know, this one's a little bit different. One thing to keep in mind, if I'm a lamp manufacturer, I'm probably not testing this lamp with the bulb installed. Okay, so this is probably not going to be here. So that just makes it all the more important to verify that this product is in fact wired properly, and that whenever I go through and I do this test, that the power switch must be in the on position to make sure that this circuit between the switch and the hot conductor going into the bulb gets tested. If this switch is not closed, this circuit basically would not be tested if this bulb is not installed here. So, you know, whenever I do a Hipot test, I want to make sure that this switch is closed, otherwise this circuit never gets tested. Again, I'm applying high voltage to the hot conductor. It goes in, goes through the fuse to the switch. I'm applying it to the return. It is on my neutral side, or not to the neutral, not to the return, I'm sorry. And that is testing the neutral side, applying high voltage to that. My return lead is connected to the enclosure of the product. Again, this is our ground circuit, and that is tied to the enclosure of the product here. So that whole circuit is basically tied back essentially to earth ground during normal operation. And what am I testing whenever I'm doing my Hipot test? I'm testing the insulation between my hot circuit and my enclosure. There is a certain amount of capacitance in this product that is going to create some leakage current. What is a capacitor? A capacitor is two conductors separated by an insulating material. You have the hot conductor, and you have, you know, you've got this hot conductor setting here that is now energized from my Hipot, and we've got the enclosure of the product is basically connected to earth ground, and there is capacitance between these two circuits that will allow leakage current to flow in this back to earth, or, you know, through the product or through the person that may be contacting this if it doesn't have an adequate ground. Okay, so it's important that I go through and I test my product again with the voltage applied both to the hot circuit and to my neutral circuit, so I'm making sure that all portions of this is actually being tested. Because if this bulb is not there, this and this switch is not closed, then this circuit is not being tested. And you know, that's important that that's power switch be in the on position. So, you know, we're applying high voltage potential to the hot and neutral conductor simultaneously. The return is connected to any exposed dead metal, and we are applying a potential, typically rule of thumb, 1,000 volts plus twice the input voltage. If it's a routine test, anywhere from 1 to 5 seconds. And we're making sure that the insulation does not break down. What constitutes a breakdown? Excessive leakage current. How much leakage current is excessive? It depends upon the safety standard. Some safety standards will tell you to set the sensitivity of the Hipot to something that is slightly higher than what the product would normally draw whenever you're performing a test on the product itself. So, you know, if you test a product and you see that it's drawing 1 milliamp, you test another one and it's drawing about 1.02, and you test another one, 1.05, you know, and you test another one that's maybe 0.98, okay? So you're right around the 1 milliamp point. So where do you set your trip? You might want to set it to something slightly higher than that. Let's give it a 50% margin, you know, even. Let's go to 2 milliamps. So if we set the current trip to 2 milliamps for a maximum high limit, maximum allowable current trip, if there's anything that goes on goofy within the product, I will typically know about it as a result of going through and doing this test, okay? I can set a low limit, maybe set a low limit to, you know, 0.8, you know, 0.7, somewhere around in there, enough to make sure that whenever I perform a test that it is seeing some leakage current through all of these circuits, okay? Now, you may not have enough of capacitance variation within your product to know whether this switch is open or closed. A lot of it is going to be depending upon the design of the product itself. But I have seen in a lot of cases where, you know, if I have my limit set tight enough, I can tell whether I have my power switch in the open or closed position by setting up both a high and a low limit. At a minimum, I know whether I have an open test lead or not. Now, if I'm doing a DC test, we have what we call a charge low feature that also can measure the charging current that occurs whenever I initially start my test. And in many cases, you know, I can tell whether the device is tested or connected or not, you know, during the test and stuff there. Okay. So it's important to go through and, you know, again, set your limits properly. Some standards may call for using a 120 k ohm resistor for setting the trip sensitivity of the Hipot. You know, that's very common. Household appliances for a routine production line test tell you to set the current trip anywhere from 5 to 30 milliamps. Why such a big variance? Appliances can vary all over the map. You know, if you're talking something that is relatively small, you know, versus something that may be quite large, such as a big refrigerator freezer type thing that you know, could have a much higher leakage current as a result of its just physical size, okay? And you know, the motors involved, the you know, compressor, you know, whatever all is involved in the circuitry and stuff there. Okay. Whenever you're doing a test, Again, a Hipot test, you are looking to make sure that the insulation does not break down. What is a breakdown? Again, a breakdown is an abrupt increase in the flow of the electrical current based upon the applied voltage. It is a complete failure of the dielectric material. A breakdown is also considered to be a disruptive discharge. That is a discharge that bridges the insulation, reducing the voltage across it practically to zero. Leakage current, again, you know, what is leakage current? It's an undesirable, typical small value of stray current that flows either through or across the insulation of the dielectric capacitor of the product itself. Every product has a certain amount of capacitance. It's going to have a certain amount of leakage current depending upon you know, the capacitance of the circuit, the applied voltage, the frequency of the applied voltage. All these things are variables that can change how much leakage current is actually flowing through your product itself. Again, where do you set your trip point? A good rule of thumb is to set it to something slightly higher than what your product would normally draw. Check your safety standard. You know, make sure that you are testing in accordance to the standard. You know, some of the problems that I have seen over my 44 years of experience, some of the safety agencies, you know, they go, you know, when they come in and they do your quarterly inspection or semi-annual inspection on your product, they are there to verify, to make sure that you are testing in accordance to the product, or to the safety standard, that your product is being manufactured the same as what it was listed under, okay? Where they went through and they did the agency listing on that product. They're trying to verify that it's still being manufactured the same, with the same components, that it is being tested properly, that you have test results that can verify that you are in fact testing it, that you can demonstrate that the test is being done, that your equipment has been calibrated, and most of the time minimum interval is annual, you know, calibration and stuff on the equipment, but they also want you to do a daily fail verification. And what is the purpose of that? The daily fail verification is there to give you some reference point that you know for a fact that you have tested your instrument that is doing this test to verify that it will detect a failure. You have some point of traceability that if you have to, you can retest a day's worth of production if by chance you find a problem, okay? So, you know, if you're doing your daily fail verification and it's doing a good enough job to make sure that it is will detect a failure, then, you know, if you detect a problem, uh-oh, wait a minute, this thing should have failed whenever I did this. When was the last time that I tested it and it worked properly? Well, I did it this morning, okay. Well, now I can go back and look at every product that I produced, and from that point on, and retest it if I have to, you know, once I make sure that my Hipot is working properly. So this is important, to make sure that you do a daily fail verification whenever you're doing a Hipot test. Okay. I mentioned some of the standards, some of the variations. Here's some examples. EN 61010, 2001. This is for laboratory equipment. It says no breakdown or repeated flashover shall occur. Corona effects and similar phenomena are to be disregarded. This is what it says for both type test and routine production line test. EN 60335 for household appliances as a type test says no breakdown shall occur during the test. The high voltage source, which means your Hipot tester, must be capable of supplying 200 milliamps under a short circuit condition, and the trip value shall not be less than 100 milliamps. This is a very high output current capacity source. Part of the reason behind this is they want to make sure that it is supplying a proper voltage to the device under test, because these tests are normally done for a longer period of time. Again, they want to make sure that the voltage does not sag during the testing process. So part of the reason for having a high current capacity source is to make sure that it is regulated well enough that it will be able to produce this current. As a type test, I don't have too much of a problem with using a high current source. I've got more of a problem using it on a production line, and typically that's just due to training of the operators. You got to remember the test, whenever you're doing a high voltage test, you are applying a high potential. Thousands of volts in some cases, to a product's insulation. If the operator makes a mistake and they come across this high voltage potential, is it going to create a startle reaction where they just receive a slight electrical shock, or is it going to be lethal where it could either do some serious damage or potentially kill an operator? And whenever you're talking about an instrument with this kind of current capacity, it has the capability of doing that. So again, you want to make sure that the operators are fully aware of the hazards involved, that you are complying with OSHA standards in setting up a safe testing environment, that you guard anything against direct contact, you are wearing the proper personal protective equipment if you are dealing with exposed energized sources, this kind of stuff. Typically, the testers that are used in most of the production environments, as long as you have an instrument that has a regulated output, you're monitoring the voltage on the output. In most cases, you can use these testers with a smaller current capacity, and testers today are much safer than what they were years ago, because a lot of them have more multiple trip devices. They have multiple shutdown circuits for high and low currents, for arc detection, for GFI circuit protection. So there are much safer testers that are being designed and used today than what there were 10, 15 years ago. You might want to take a look at some of the newer Hipots and stuff just from that standpoint. Okay. Again, 60335, which is for household appliances, as a type test requires this high current, but as a routine production line test, it does allow you to use a tester that has a current trip capacity normally ranging from about 5 to 30 milliamps. As long as the high voltage transformer is capable of maintaining the specified voltage until current trip flows, then the tester is allowed to be used without requiring a 100 milliamp tester that in fact could be lethal if the operator gets on the wrong end of that tester. EN 50116 for information technology says no insulation breakdown shall occur during the test. For the purpose of this standard, insulation breakdown is indicated by a trip current. It is defined as any significant increase from the steady state current measured during the electrical strength test. The test equipment shall provide a means of indicating the test voltage. The insulation breakdown must show either a visible or audible alarm. Trip level is determined by the manufacturer, basically of the product actually being tested. It says test equipment, but it's the test equipment actually being manufactured. You make the determination whether to set that trip point at. Trip current should be set at a minimum practical value. It is usually in the order of a few microamps if you're doing a DC test. If you're doing AC, you must take into account any leakage current that could be flowing through the RFI filter capacitors when setting up your trip point. Okay. Medical equipment, 60601-1, each appliance shall withstand without an indication of unacceptable performance as a routine production line test the application of a 40 to 70 hertz AC potential or a DC potential of 1.414 times the stated AC value. All the primary wiring and current, including connected components and accessible dead metal parts that are likely to become energized, are essentially tested. Primary and accessible low voltage metal parts, including terminals where applicable, and primary circuits to patient leads connected in the circuit. So all of these circuits are in fact tested whenever you are performing a Hipot test. So it may be not only requiring one test, but you may be doing 2 or 3 tests to make sure that you're testing all of these circuits, and they may be done at different potentials. Okay. Unacceptable performance is described as when the test equipment is adjusted to produce the test voltage. A resistance of 120,000 ohms is connected across the output. The test equipment is to indicate an unacceptable performance within 0.5 seconds. A resistance of more than 120,000 ohms may be used to produce an indication of unacceptable performance if the manufacturer elects to use a sensitivity or a tester having a higher sensitivity. Okay. This standard also requires that the output of the test equipment be regulated under both varying line and load conditions. So again, your testers today have multiple failure detectors, one for arc sensitivity, one for leakage, an overload. Why multiple failure detectors? Depending upon which one of these things go off, we can give you a lot more information about how your product is actually performing, what type of failure you're actually having. The arc detector only responds to high frequency noise. The leakage detector is the adjustable detector that you can set for your trip point. And then we have an overload detector that basically is set at the maximum current capacity of your instrument itself. In many cases, depending upon which one of these detectors actually goes off, that information or shutdown is fed into the CPU, into the unit. If we have just an arc that occurs and it doesn't trip off either the leakage current or the overload detector, it's just going to say arc fail. Okay. If you have a high limit or a low limit failure, that is going to be shown up on the display of the instrument just due to either high or low leakage current. If you have an arc fail in conjunction with an overload, where you've exceeded the maximum capacity, the display on the unit is going to say breakdown. If you have just an overload, that essentially if you had a short circuit in your device under test, this detector is going to go off before anything else because it's on a high-speed shutdown, and that will give you an OFL type failure indication. So depending upon which one of these detection networks is going off in combination with any others, we can give you much more information on what is going on with your device that is actually being tested. Okay. That concludes our presentation here today. We're going to leave it open just for a couple minutes here. If you have any questions, you can go ahead and shoot them over the Q&A facility, and I will go through and answer those. I'm going to throw the question out to Pete or Saeed. I don't know if we've got anything that came in that we need to answer. Or,
Dwayne, just taking a look, everything seems to be covered at this point as far as any inbound questions, so nothing's left unanswered at this point.
Very good. Thanks, Pete. Again, we'll hold it open just for a couple more minutes, but I'd like to thank everybody for attending. If you'd like to see part 2 of this, join us next Wednesday at 10 a.m. Central Time, and we will go through part 2 of Hipot testing basics. And I want to remind everybody, we try to conduct these webinars a minimum of once a month. Normally, some months we have multiples. Typically, July we try to stay away from because so many people are taking vacations, this kind of stuff, and around the Christmas holidays, this kind of stuff, we try to finish up before then. We do record all of our presentations. They are available on our website if you would like to review them at any time. They are great training facilities that if you have somebody else that you thought, well, hey, this may help in answering some of their questions, please feel free to log on to our website. It's going to ask for a little bit of information from you to make sure that you are at least in our mail list, so we can send you out information if you would like. And they are great training tools. I haven't seen any questions come in, so with that, I'm going to go ahead and close this out. And again, thank you for attending, and hope you will be joining us next Wednesday at 10 a.m.